In this video, I am going to show you what is fuel and crude oil. This is the introduction to organic chemistry, and the first thing you need to know is fuel and crude oil. And what exactly is fuel? Fuel is burned in air to produce heat. You know, we use fuel for vehicles, we use fuel for aircraft, we use fuel to cook. So fuel burns in air to produce heat. I'm going to write it down to show you. So this is fuel, or I can just write burn in air to produce heat. Okay, so the main sources of energy, or known as fuel, are natural gas, petroleum, and coal. So you need to know they will break up into three things. So we have our natural gas. Okay, natural gas, petroleum, okay, and then we have our coal. Okay, so these are the three things that you need to know for fuel, the main sources of energy. And natural gas, they contain mainly methane and petroleum. So this natural gas contain mainly petroleum, and one more is methane, your CH4. Okay, so this is the first thing that you need to know for natural gas. And hydrocarbons are in crude oil. Okay, so this crude oil, we have our hydrocarbon. Okay, hydrocarbons are molecules that contain only hydrogen, and your carbon. So this will give us something like methane, CH4. So methane is a hydrocarbon, and crude oil, they contain many hydrocarbon, and they are separated by fractional distillation. So fractional distillation. Okay, because of their different boiling point in crude oil. Crude oil is a mixture, so we can separate them into useful components by fractional distillation. Alright, so I'm gonna show you in a while. When you separate crude oil, what do you get? So the first thing that you get at the top of the fractional column, okay, so this is a very big project. You don't see it in a lab. Okay, so I'm gonna show you here. So you have something like this. I'm gonna draw a very simplified version of the fractional column. Okay, so at the top you have your gas. Okay, the ones that boils easily, the ones that turn into gas state will escape. Not exactly escape, you'll just go to the top and we'll collect it as a gas. The one at the bottom usually is solid. Okay, so we have different types of layer. So we're gonna get different types of component. And the first thing that you need to know at the top of the fractional column, you have your petroleum gas. Okay, so this, we are separating crude oil, your petroleum. So take note that petroleum is also known as crude oil. Okay, so this is the thing that you need to know. And at the top we have your petroleum gas. So I'm going to write at the top here. So at the top we have our petroleum gas, and this petroleum gas is used for cooking and heating. So I'm gonna write it down for cooking and heating. Okay, so followed by that we have our petrol. Okay, as you go down from the petroleum, as you go down from this column, you're getting from gas all the way down to liquid, then solid. Okay, it's because of the different boiling point. So the next we have our petrol. Our petrol. And petrol, what does this use for? It's used for vehicles, right? Fuel for vehicles. In order for the vehicles to move, we need fuel. Alright, can. Now the next one we have our naphtha. Okay, naphtha. Okay, this is, what is this used for? This is used for making plastics or and detergent. The next one we have our kerosene. Okay, our kerosene. This kerosene, okay, is used for fuel for aircraft, also used for cooking and heating, but it's much more in a liquid form, so it's good for it to burn for aircraft. So this is used for aircraft. Also it can be used for heating and cooking. Okay, next we'll move on to, after below kerosene we will have our diesel oil. So we have our diesel. Okay, so this is used for large vehicles, like for example buses, lorries. Okay, so trucks, all this is used for trains, for big vehicles. And after diesel we have our lubricating oil. So this is our lubricating oil. And lubricating oil, by the name you know that this is to use to lubricate machine, making wax. Okay, so it's used to reduce friction. And the last one down this on this list of names, we have our bitumen. And bitumen is the one that we use to make roads. Okay, it's used for making roads. Okay, what you have to remember this by heart in order from the top to the bottom. And take note that we have another name for our petrol and kerosene. So for petrol, you can call it gasoline. Alright, so in some countries they call it gasoline. And for kerosene, sometimes they call it paraffin. So you need to take note of this. They have different names for those two. And the rest is all like this, from petroleum gas, petrol, naphtha, kerosene, diesel, lubricating oil, and bitumen, all the way at the bottom. Okay, now we'll move on to organic compounds. I'm going to explain to you what is organic compound and how you're going to name it, and what are the different types of homologous series and what exactly is homologous series. Okay, so the first thing is, what is organic compound? Okay, what is organic compound? So here we have organic compound. So anything by organic compound. Okay, let me erase this at the top. Okay, so for organic compounds, we have elements, or we have molecules that contain carbon. So they contain carbon. So we have our carbon here in organic compound, and those that are known as hydrocarbon, as I went through earlier, they only contain hydrogen and carbon. So for hydrocarbon, they contain our hydrogen and our carbon. As you can see, hydro means hydrogen, it means for hydrogen, and carbon means for carbon. So these compounds, they only contain these two. So for hydrocarbon, we have what we known as our alkane. So we have our alkane and our alkene, because these two, they contain only hydrogen and carbon. But for alcohol and carboxylic acid, they have oxygen with it. So they are not known as hydrocarbon except for these two, alkane and alkene. Okay, so what is homologous series? So homologous series is a family of organic compounds with the same or similar chemical properties, same functional group, same general formula, but slightly different physical properties. So I'm going to go in that in a while. So the first thing to take note that alkanes, we have methane, we have ethane, we have different names to it, and they are known as homologous series. So this can be a homologous series. So we can say that alkane has a homologous series because alkane, we have many different types of alkanes. We have our methane. I mean, they are under alkane. Okay, we have our ethane, and we have our propane. As you can see, these three, so these three, they are known as a homologous series because they are under the family of alkane. So they are a homologous series. So take it, for example, homologous series is just different names, but they are under the same community, they are under the same types of compound. Okay, there's the same type of molecules. So that is why they exhibit or they show similar chemical properties due to their functional group. And what is functional group? So I'm going to write it here. They show similar chemical property. And what is functional group? Because of same functional group. Okay, so functional group for alkanes, we don't have the same functional group. Okay, so for alkene, we have same functional group. So for alkene, it will be C double bond. So carbon-carbon double bond, but alkane is a single bond. But we can not say that alkane have any functional group because alkane is only a single bond. But they do have the same general formula. And alkane general formula, you need to take note that is actually CnH2n plus 2. So let's say, for example, I'm going to sub in one carbon inside. And if we put n is equal to 1, we have C1H4. Okay, so you're going to substitute inside. So I'm going to show you how you're going to name your alkane first. Okay, so but take note that they are alkane. We have methane, ethane, propane, and so on. They are the homologous series of alkane. They show similar chemical properties because of their same functional group, and they have same general formula. And you need to take note that they have different physical properties, like different boiling points because of their different chain length of the number of carbons atom per molecule. Because methane has 1 carbon, ethane has 2 carbon, propane has 3 carbon. So because of their different numbers of carbon, they have different physical properties. So let's go straight into the naming of alkane, and I'm going to show you alkane. And so that will be for this video. I'll just move on to alkane and alkene, and the next video I'm going to show you on alcohol and carboxylic acid. But this is the introduction to your organic chemistry. So for the first one, we have our alkane. So I'm going to write here alkane. Okay, I'm going to use this to write. Okay, so for alkane, we have, you know that the general formula is CnH2n plus 2. So let's say, for example, I have my methane. Okay, by now you should know that methane is CH4, but how do you get to that? Okay, so you need to take note that this methane is, you can break it down into two simple word or subword. So you see here you have the math, the myth, and you can see here that the ANE at the back, that is the ANE at the back for this. Okay, can you see this? We have the ANE here, and we have the ANE there at the back of the methane. This shows you that it's a alkane, and the one in front shows you that it contains one carbon. So that is why when we sub in one carbon, we have our C1H21 plus 2, and you'll get it into CH4, and this is your methane. And I'm going to go on to the next one. I'm going to show you ethene. Okay, so let's say for example now I have my ethene. Okay, I'm going to break it down into two, so you can see that this is my alkene family. And oh yeah, by the way, alkene, their general formula is CnH2n. Okay, I'm going to show you how we're going to do this. And then we ETH, this subword, the one at the front, this means that it's 2 carbon. Okay, 2 carbon. So we're gonna sub in 2, C2H22, and this will give me C2H4. So this is my ethene. Okay, so but take note that for ethene, I'll go in depth into each of the alkane and alkene later on, but take note that for alkane, for alkane, it doesn't, it has methane, but it does not have ethane. Okay, sorry. So what I'm saying that for alkane we have my methane, right? But for alkene we do not have methane. Why is that so? Because of the carbon-carbon double bond. But you can see that alkane, it has only a single bond. So yes, I'll go in depth at the later part of the video, and another video. Okay, so right now you need to see that methane and ethene, this is the naming of it, the organic compounds. And I'm going to draw the structural formula out for you to see. Alright, the example for methane. And okay, so methane is going to be CH4, right? So you can see that it's a single bond around the carbon, but for ethane, we have a double bond first. Only one double bond, take note. It's only one double bond. Okay, and there you go. Here's my structural formula for ethene. So you need to take note the back of the name to know which whether is it alkane, alcohol, carboxylic acid, and one at the front shows you the number of carbon. So for example, we have, so this is 1 carbon, this is 2 carbon, and this is 3 carbon, and this is 4 carbon. So this is 1 carbon, 2 carbon, 3 carbon, and 4 carbon. Okay, so that is all for the introduction of organic chemistry. I'm going to show you in the next video on alkane. Then we go to alkene, followed by alcohol and carboxylic acid. Okay, so I'll see you in the next video. I'm going to show you on alkane, physical properties and chemical properties. Okay, thanks for watching, and I'll see you in the next video.